Okay, let's do condition. Sorry. Let's do conditional probability. We have what's implied is that there's A, and then there's B given the A. That's what's implied for this. Like you're going to see the given, but and we saw that the probability of A and B, once again, A happening and B happening is equal to the probability that A happened first, and then the probability that B happened given A. We went through that. That's the idea, and we did the branches. So algebraically, if we think about this, that means the probability of B given A is equal to the probability of A and B over the probability of A. And if you look at this and you think about this, you're like, this is a probability. It's the probability of something is a fraction. And if you kind of you think, well, wait a minute, so the denominator was like the sample space, right? And so I like to teach the conditional probability as A is the new 100%. That's the idea. It's the sample space, but it's the new 100%. So what's the example? So I start with, and this is like a possibility. So the example I like to start off with is about luggage. So what is it reflecting? Oh, let me think that. So my example is luggage. So I want you to imagine lost luggage. Okay. And the first flight is Air France, and you lost your luggage. That happens, right? The next experience, you took Air France again. They gave you like a voucher. You're like, fine, and you found your luggage. You picked up your luggage. And then finally, you wanted to go to Doha, so you took Etihad, and unfortunately, you lost your luggage. So the question is, the first question is, what is the probability that you lost your luggage? And you say, okay, there's three, incidences, and I lost it twice. Now I'm going to change the question to, given that you flew Air France, what is the probability that you lost your luggage? So you could use the formula, but I like to view this as, so this is the new 100%. So if Air France is the new 100%, I'm only looking at the Air France incidences. So, there was only 2 of them, and I lost my luggage one at a time. So given that I flew Air France, there's a 50% chance that I lost my luggage versus, in general, in my whole life, there seems to be or maybe at this airport, there seems to be a 2/3 probability, and that's the idea. Now, obviously, we could use the formula here. What is the formula? It's the probability of losing your luggage and going to Air France divided by the probability that you flew Air France. Well, the probability that you lost your luggage and you flew Air France is 1 out of 3 because Air France, the first selection is the only way to satisfy both of these conditions. So that's 1 divided by 3. And then what's the probability of Air France? Well, that's 2 out of 3. And therefore, that gives us our 1/2. Interesting. Let's try another problem. Let's try to bring it together. So I'm going to erase this. Here's another scenario that I like to talk about conditional probability. So let's see. We're gonna roll a 10-sided die, and the numbers are from 1 to 10. Okay, and I want you to. Well, The question I'm going to ask you is, what is the probability that it's odd given that the roll is prime? So, you know what, let's make a Venn diagram here. Let's just fool around with this a little bit. So we can make a Venn diagram, and this is the universe, so this is 1 through 10. I'm interested in odd and prime, so I'm going to make intersecting circles in odd and prime. Let's just go through the numbers. 1. Where is 1 located? Well, 1's over here. It's not prime, but it is odd. How about 2? Well, 2 is prime, but it's not odd. How about 3? Well, 3 is odd and prime. Where's 4 go? Not in these 3 spaces, but out here. What about 5? Well, 5 is odd and is prime. 6? Out here. 7? 8? What about 9? Well, 9 is odd, but it's not prime. And 10 goes out here. So let's just do a couple. First of all, what is the probability that it's odd? Well, 1, 2, 3, 4, 5. 5 out of 10, or 1/2. What's the probability it's prime? Well, there's 4 prime numbers out of 10, so it's 4 out of 10. 40, 2/5, so 40%. What's the probability that it's odd and prime? What's the probability it's odd and prime? Well, there's 3 in the intersection, so it's 3 out of 10. Now, let's talk about this. What's the probability it's odd given it's prime? Well, this is a different type of construct. Please remember, this is our new 100%. So you know what? I'm only interested in this circle. I'm only interested in that girl. Well, we can visually see odd given it's prime. I can see 3 over 4, or 75%. That's different than odd and prime, which is only 30%. Once again, P is my new 100%. There's four numbers I'm interested in looking at. There's only 4 primes, 2, 3, 5, 7, and 3 of them are odd. Nice. How about what's the probability of being prime if it's odd? That's something different, right? Let's do that in blue. I'm going to do that in blue marker. Well, odd, this is my new 100%. I'm only interested in these 5. I'm only interested in these 5, and the ones that are odd are the ones that are prime, 3 out of 5. So that's 8. Can you use the formula for these? Yes, obviously you can use the formula for these, and you'll get the same answer. This is 3 over 10 divided by the probability of P, 4 out of 10, which is 3/4. That works out nicely. What's going on over here? Same thing. 3 out of 10, 3 over 10 divided by odd, 5 out of 10, which is 3 out of 5. And so the idea, yes, you can always use the formula, but I want you to really think about, I hate not finding the cap, here it is. I want you to just really think about, this idea, this new 100%. And then the last problem in the book is they talk about people who live in Japan and how they're millionaires and they live in mansions. So let's look at this problem. This one is strictly, just plug it in the formula. Plug it in the formula and then see what happens. So we're told that the probability, people who live in Japan, the probability that you're a millionaire is 1 out of 10,000. The probability you live in a mansion is 1 out of 30,000. And the probability that you're a millionaire and you live in a mansion is 1 out of 40,000. 1 out of 40,000. So first of all, I'm going to let A be a millionaire. And this is right out of the book. I'm just substituting this because I don't feel like writing millionaire. Oh, B is mansion. Okay, and then I'm going to pull C, A, and D just for a second. So we know that the probability of A is equal to 1 over 10,000. we know the probability of B is equal to 1 over 30,000, right? And we know the probability, we're told the probability A and B is equal to 1 over 40,000, which is not equal to the probability of A times the probability of B. So because they're not independent, one depends on the other, and so you expect a given statement. Well, they tell us, they want us to find the probability, so find the probability that you're a millionaire given you live in a mansion. And yeah, and so this is strict formula. I mean, you don't want to make a Venn diagram, I'm not really sure. This is strict formula, the probability of A and B over the probability if I knew 100%. We have 1 over 40,000 divided by 1 over 30,000, and we end up with 3 over 4, or there's a 75% chance that a person is a millionaire given that they live in a mansion. Once again, I'm only looking at the people who live in mansions. That's the idea here. And we're going to extend this in the next unit for, when we talk about Bayes' theorem and the idea of we're only interested in a certain subset of the population, specifically with vaccines. Our question is going to be, given that the person tested positive, did they actually have the disease? So anyway, try these problems in 22, the conditional problem. I think it's 22F.